This class, my assignment is to introduce our department. But I only have less than 2 hours, so I just can give you a very brief introduction about our department. So where am I? Why I'm here? And why you are here? But this is not that. Okay, so I'm Izzy Wang. I'm a professor of civil and construction engineering department. And also, my another role is a vice chair. So totally, we have 2 vice chairs, and I'm one of the 2 vice chairs. So you maybe know our department a little bit. So our department was established in 1975, and 1 year later, we started to provide the bachelor program. And in 1979, we started to provide the master program. And 4 years later, we started to provide the PhD program. But those are for local students. So in 2005, after we take a few years to recruit international students, and then we start to provide international student program. But this program is only for graduate students. And then 5 years later, we start to provide the dual degree international program. And 3 years ago, we started to provide international student program for undergraduate students. And the most of you should be familiar with this program because our government established a university in Taiwan, Paraguay University. So we have some cooperation. Then students in Paraguay, 2 years in Paraguay and 2 years in NDSD. And this year, this is the first year, the 3rd grade student in Paraguay came to NDSD campus. And should emphasize that here in 2007 and 2008, our department received IEP accreditation for undergraduate and graduate students. And this certification is very important, especially when a student graduates from our department, they may choose to pursue the master or PhD degrees abroad. So after student they receive a diploma, and this diploma is recognized by the Washington Accord. So in other words, you can use this diploma to apply the university in each member of this accord. And they will recognize your diploma and admit your application. Okay, so this is the details of accreditation. We received accreditation of engineering technology education programs by IET. The full name of IET is the Institute of Engineering Education Taiwan. And of course, Taiwan is one of the 4 signatories of Washington Accord. So as shown in this map, you can see that right now, totally, there are 17 signatories, as well as additional 6 professional signatories in this accord. And of course, Taiwan is one of these members. So as I mentioned, the benefit of this accreditation is that students, when a student graduates from our department, and their diplomas can be recognized by any member of this group. And then they can apply master or PhD degrees. So it means that those universities in these countries, including USA, Canada, UK, and so on, Japan, and so on, can recognize your diplomas if you were NTUSD, our department graduates. And about the international reputation of our department, this is the latest statistics. 2023 in the global, our university here, the banking, 327. About in Taiwan, so our university is top 5. If we only focus on our department, civil and structure engineering in the global, the ranking is 151 to 200. And our department is the top 3 in Taiwan. The following is about our faculty and staff members in our department. So now we have totally 32 full-time faculty members, including 18 full professors, 13 associate professors, as well as 2 assistant professors. So those are the tenure professors. In addition, we also hire 8 non-tenure faculty members, 3 joint appointed faculty members, as well as 80 the part-time faculty members for teaching. In addition to these faculty members, we also, for administration, we also have 8 staff members, including 4 to support the administration affairs, and the other 4 for supporting technical jobs. For example, like to provide the service for testing and maintaining the existing testing facility in Greenland. Okay, so this guy, this is our current chairman, Professor Cho. And his major recent topic, this is about the deterioration analysis for reference country. Also, his focus, another focus is about the risk, the management, durability, the design and maintenance of a reference country. And it's me. So I'm one of the 2 current vice chairmen for our department. So my major research is about earthquake engineering. Also, I study some advanced structural control technology, like seismic isolators and dampers. The other chairman of our department, Professor Ken. So his major is about bio-mediated soil improvement conceptual model for soft soil and urban geoengineering and so on. For graduate students, our department now we have 5 research divisions. The construction management, this division, this is the earliest division. Focused on construction management. This topic is the first earliest division in Taiwan, established in Taiwan. And construction material, information technology, geotechnical engineering, and structural engineering. So I will give you details about these 5 divisions later. So the following are a brief introduction of our faculty members. So you may observe when you enter this building, if you see the right hand side, the board, the bulletin board. So you may observe that actually we show all the faculty members of our department. And here I just can give you some very brief introduction for each guy. And if you're interested in the details, here I show the QR code. Okay? So through this QR code, we can obtain more details about each professor. That's for later, the major research topic, interest, and information about later lectures. So for this division, the construction management, now we have 6 effective members, including Professor Liu, Professor Chen, Professor Yang, who is the chairman of our department, and Professor Zhou, Professor Li, and Professor Hong. Geotechnical engineering division. Right now, currently we have 7 effective members, including Professor Chen, Professor O, so who recently just got the great award in the whole world. And Professor Liao, Professor Lin, Professor Lu, Professor Li, and Professor Chen, as I explained, and he's another chairman of our department. Structural engineering division. Right now we have 13 effective members, including Professor Huang, Professor Chang, Professor Chen, Professor Chou, he's the current chairman, Professor Chen, and it's me. Also, Professor Han, Professor Chen, Professor Huang, Professor Xu, Professor Chen, Professor Xiang, who is also the Vice Dean of General Affairs in NTUST, and Professor Xu. In the construction material divisions, now we have 4 effective members, including Professor Yang, Professor Chen, Professor He, and Professor Liao, who is also the Vice Director of Hsinchu. So you know that in addition to Taipei campus, we also have Hsinchu campus. So right now he is the Vice Director of Hsinchu campus. For the information technology division, so we have 3 effective members, Professor Chen, Professor Xie. So you should be very familiar with this professor, Professor Xie. He's also a chairman of interdisciplinary bachelor program. Also, he is the Vice Dean of Academic Affairs in NTUST. And that's one, Professor Tan. He's also Section Chief of a Division of General Academic Affairs. So, after I introduce the members, and then I'll give you some brief introduction about the course program. For undergraduate students, we provide the courses program, and in addition to provide the fundamental, theoretical, the knowledge. We hope that after taking the courses, the students can understand how to practically apply this knowledge to a real, practical engineering project. So we hope that after taking these courses, students can have abilities to carry out experimental work and practical training. So in other words, the objective of our courses arrangement is to bridge theory and practice. Okay, so the first, this is these are compulsory college courses for undergraduate students. And in addition to the compulsory courses, our department also provides compulsory professional courses for different levels, for different degrees. The freshmen, sophomore, junior, and senior students. And also, we provide the professional practice, the classes as given here. And for undergraduate students, we also provide elective professional courses. So when students are a junior or a senior students, they may be interested in some specific revision topics, and then they can choose. They can choose these classes. So these classes can be classified as five parts based on our the research divisions. For construction management, geotechnical engineering, structural engineering, construction material, and information technology. In addition, we also provide some courses related to learning some skills or learning some readily available analysis programs. As given here. And also we provide some courses to make the students have some practical experience about the real case, the real engineering projects. And the following are graduate courses. And of course, we provide these courses based on our 5 research divisions. Construction management, geotechnical engineering, structural engineering, construction material, information technology. So in addition to in addition to these courses provided for full-time students, our department also have a part-time master's programs. And for this program, the courses are shown are given here. And because, as I mentioned, because we have international program, so this one is one of the international program, dual degree master program. So we also provide some courses for this program, dual degree master program. Okay, so this slide shows some major research topics in the first research division, construction management. So here I just introduced 4 the parts. The first part is the project management. So the research topic, this is about the risk, the management, the financial, engineering, decision support, strategy management. The second part is how to plan and design the building more effectively and more efficiently. So some research topics including isolation, scheduling, and how to design and construct green and smart buildings. The third part, this is for infrastructure systems. So how to maintain, how to arrange the maintenance and management project, and how to plan, how to have effective and sufficient disaster management. And the final goal, of course, we hope that we can have a sustainable engineering. And the last one is by using some advanced tool. And then we can have the more effective and more efficient management the plan by using artificial intelligence, optimization, algorithm, and IoT, Internet of Things, beings, and the simulation. Okay, so if we try to just briefly understand what the major research topic for this division, the construction management. So we can just use this 4 part to give you a very brief introduction about this division. The second division, the geotechnical engineering, as indicated by this word, geotechnical. So means that we have to solve some geotechnical problems. So some research topics including energy and sustainable engineering, and the rock mechanics, the rock tunneling, and how to deal with how to solve the rock slope. And if we have a slope, for example, landslide, you may notice recently we have a news for highway. Right, friend? I forget the exact location, from Xiji to Taipei or from Jiwon to Xiji. So we had a landslide, the slope slide, the problem. So fortunately, we don't have any injury to people or, some death. We just have a problem about the traffic. Okay. So how to deal with this the geotechnical problem, slopes, and this, of course, a major research topic for this division. Also, the ground improvement, what does it mean? It means that this is a very important, especially for the highly populated areas such as Taipei City. If a location you choose to build a structure, if the location, the soil condition, the ground condition is not good enough, so we can just use this method, this strategy. We replace the existing soil by other materials which can guarantee the safety of the foundation design. And the last one, this is urban geoengineering. Likewise, this is very important for the urban, like Taipei City. For a crowded city, so how to process the foundation of geotechnical engineering. This is a big issue, a very important issue. So because we don't hope that this foundation construction affect the people or affect the usual operation, the usual functionality of the structure or people nearby. And so this is a very important, this is necessary research topic for developing countries. And for this division, we have two laboratories. This is the first one, geotechnical laboratory. In laboratory, we provide many conventional and advanced testing systems, including the register, the testing, static and dynamic triaxial, the testing, the system, and straight path apparatus, triaxial quick, seismic detecting, cruise hole, and also we have some advanced equipment like GIS and GPS and monitoring system. So by using this type of system, we can, of course, we can numerical and theoretical study some topic. And by using these testing facilities, we can further experimentally verify our theoretical and numerical result. This laboratory is another in this division. The rock mechanics laboratory. In laboratory, we have one universal testing machine with the force capacity of 100 tons. In the rock triaxial cell with the capacity up to 20,000 psi confining pressure. And other testing systems such as the rock vector shear testing, the rock fracture, and so on. The structural engineering division. As this word indicates, structure means that we have to solve the structural problem. So obviously, this problem including how to design the building, and how to inspect the existing building if this building has some damage during earthquake or during some external loading cases such as wind. The first one, the life cycle management and rehabilitation. As I mentioned, this is a major research topic of our chairman, Professor Cho. And also, this is quite different compared with the research topic in the structural engineering division for other universities in Taiwan. And the structure types, the diverse structure types, of course. for traditional structure types, including reinforced concrete and steel structures. So those are our target. In addition to the traditional structures, recently we have the combination of reinforced concrete and steel, as you know. And typically for low-rise building, usually we use reinforced concrete. For high-rise or for super high-rise or skyscraper the buildings. For these cases, we would like to use the steel because the steel material is lighter compared with the reinforced concrete, so that we can effectively reduce the dilation and then reduce the weight of the whole structure. So in addition to reinforced concrete steel structure, as well as the combination of a reinforced concrete and steel structure. So we also studied some hybrid. So what does hybrid mean? It means that we incorporate some advanced technologies into the structure design. For example, the seismic isolation and additional dampers. In addition to proposing some new and innovative design strategies. So we also studied healthy monitoring system, so that we can, during a real earthquake, that we can, in a real-time manner, to monitor the situation of the building. So this is the so-called hybrid, or this is the so-called smart structures. For the loading cases, earthquake, wind load, of course, those are typical loading. I mean the horizontal, not the vertical, because of course, before we consider horizontal, we need to consider vertical. Because the first priority design objective is to guarantee the structure to sustain itself, the self-weight. Okay, after we guarantee the safety under the vertical loading, and then we start to consider horizontal loading. And there are three phases we need to consider. Before the construction of the building, of course, we need a thorough design process for a new building. And during earthquake, as I mentioned, we study a health monitoring system so that we can monitor the healthy situation of the building during earthquake in a real-time manner. So during earthquake, if we have this system, we can easily inspect some damage if there is any for the structure. And after, for example, after earthquake, if the monitoring system tells us that there is really damage for this specific building, and then what strategy we should take to retrofit or to demolish the building. So this is in the after the phase. But for this division, of course, we also have laboratory. This is called structural laboratories. In this library, this is very close to this classroom. Okay, just beside this classroom. So if you are interested in this laboratory, so after class, if we earlier in this class, we used to have time to visit this laboratory. We have reaction word, the blue color here, and strong flow for statically, quasi-statically, and dynamically test specimens. So to perform this test, in addition to this reaction word, in addition to response flower, we also have some different capacity, some actuators with different capacity, including static and dynamic actuators. For static actuators, different capacity force, 50 times, 100 times, 200 times. For dynamic has the purpose, 25 actuator. So in addition to this actuator to exert force on a specimen, so we also have measurement system, including the traditional displacement transducers, accelerometers. Also, we have some advanced measurement system. This is a non-contact measurement system. In addition to this, we also have a shipping table here with the dimension of a 3 meter by 3 meter. And the capacity, the payload capacity is 100 kilonewtons. So it means that we can put specimen with the 100 kilonewton at most on this shipping table. For the bare shipping table, acceleration is up to 3.2 G. And for a shipping table with a 4 payload, acceleration is only up to 1.2 G. Okay, so in addition to these two, I have already introduced the third one. This is a universal testing machine for vertically test the compression member, for example, like columns. And the force capacity is 600 tons. The construction material, the division, to develop mechanically material and the study problem of corrosion. This is another important issue for existing structures because Taiwan is very humid and the environment is not very friendly for the structure, especially. So that's why I emphasize this is very special, and we have to pay more attention for this topic, for these issues. In the circular material, by using the West or slag, mud, ash, and to develop the circular materials so that we can have a cost-effective and more efficient construction of projects. And to develop cost-effective and the powerful the material for the pavement engineering. The solar glass. This is very the important patent and the end products for our department. And this patent has already been applied to practical industry. It has been applied to, for example, high-tech factories. And the last one, a sponge city. This is maybe you think this is a slogan. Actually, this is the final goal when we study construction material. So this sponge city means that we hope that after hazard, or any hazard, for example, like earthquake, flood, or typhoon, or windstorm, and so on, well, we hope that the city can still have a flexibility, even this hazard is exceeding our expectation. Okay, we still can resist such a large hazard. So we hope the city can have sufficient flexibility to deal with this very large hazard. So this is a so-called sponge city. And its division, we have two laboratories. The first one, material laboratories, some testing system like stress control, a VR meter, the thermal conductivity measurement device, the torque shear testing apparatus, and also material crystalline image analyzer, and so on. This is another laboratory in this division, the construction materials division. In this laboratory, so we have a universal testing system with different force capacity, 100 tons, 200 tons. Also, this one only for compression testing with force capacity 200 tons. Another two for dynamic testing, force capacity 5 tons and 100 tons. information technology. Some recent topics like the cloud for computing and surface, IoT for smart building to prevent and design and construct smart buildings. And the visualization, this is a very hot topic recently, including VR and AR. And the beam is very powerful and useful for life cycle engineering. So before constructing and after constructing, so we can have a very overall plan by using beam. And after construction, we can just use the beam to inspect any problem during the life cycle of the existing building. Superior design, high speed, high fidelity assimilation, and so on. And better to guarantee a better construction by using beam with technology. And to provide a safer world by using this technology and enabled by IT. And this division also studied a three-dimensional spatial mapping. And this is very useful, especially when we have an earthquake and after earthquake. But before, if we try to rebuild the level of the existing structures, and this is a very powerful and very useful technology. By using LiDAR, this is already available clear-vision, and as well as the UAV. The full name is unmanned aerial vehicle. And the intelligent image processing for deep learning and some special information applications by using these technologies. So in a word, in this division, after students learn the basic fundamental knowledge to use a different language and this one knowledge base, and then we can develop dialogue management, the context learning, and the response generation in this research division. So for this division, we also have some hardwares and softwares. For example, VR equipment and GPU and some, and the Microsoft Imagine subscription, so on. This is another lecture. This is about surveying. And some equipment like digital theodolite, electrical theodolite, and surveying software. So this is information technology and engineering visualization laboratory, including software and hardware that we provide right now. Okay, so this is the statistics about our local students, including the graduates and enrolled students. Until now, we have more than 250 PhD graduates. More than 3,300 master graduates, and more than 5,500 bachelor graduates. And the number per year, in average, we have 400 graduate students and 380 the bachelor students per year. So this academic year, so we have 32 enrolled PhD students, 278 enrolled master students, as well as 380 enrolled the bachelor students. About our international students, so our international students come from different and many countries including Indonesia, Vietnam, the Philippines, Malaysia, Thailand, India, China, Turkey, Russia, Iraq, Paraguay, Czech Republic, Hungary, St. Lucia, Ethiopia, Kenya, Gambia, Sudan, Eswatini, and Burkina Faso, and Benin, and so on. So I have to emphasize that for our department, a very important association was established in 2010. The name is International Student Association of Civil and Construction Engineering, ISA, CCE. So why do I say it's very important? Because this association will help our department very much. And it frequently holds activities in conference for international students. Not only for international students already in Taiwan, but also for students still abroad. So through this conference, students abroad can better understand our department. And through activities, so international students from different countries can work or can study together. And they can be quickly used to the Taiwan society and the UST campus. So for international students up to now, we have 58 PhD graduates and 287 the master graduates. This academic year, 35 enrolled PhD students, 60 enrolled master students, as well as 24 enrolled bachelor students. So this is a picture taken 2 years ago. So as I mentioned, our alumni is very powerful because we have so many graduates in the global. So the number, this is the number one in Taiwan, 58 the PhD and 287 masters. About internationalization, why? So why is our internationalization so successful for our department? This is because that until now, we already have approximately 20 years experience to recruit international students and to provide the corresponding the courses, the program for international students. And we know, as shown in the previous slide, you know that these international students come from different, diverse countries. So it means that this impact, our education has been recognized by many countries, by many students in many countries. And because of existing of the association, and we have a very good interaction between students, including local and international students in our department. As I mentioned, we received a quickly degree program, so that when students graduate from our department, if they want to pursue master or PhD degree, this is a very useful for these students. A 2+2 English program and funding for overseas activities. So we provide students with funding if they are interested in taking part in some national or international contest or activities. We can provide them with funding. Scholarship, of course, is very important. So if you are qualified some requirement, you can apply for scholarship. for master and PhD graduate programs. And of course, already know that we have a very beautiful and brand new dorm for international students accommodation. So here I just show you some universities. We have those are the partnership with our department. The countries including the North America, the Australia, Germany, Europe, many Europe countries, Japan, Korea, Singapore, and Indonesia. So about international collaboration, in addition to bachelor, master, PhD degrees, we also have the master degree. For example, we have the program with the Petrol in Indonesia. So 1 year in Indonesia Petrol and 1 year in NTUSD campus. Also, we have a dual bachelor degree program. For example, Taiwan and Paraguay, 2 years in Paraguay and 2 years in NTUSD. And we also provide many opportunities for exchanging professors and students for further study some specific research interest. And laboratory internship. If international students need to earn money to survive in Taiwan, but this is very few cases. And we can provide laboratory internship to earn salary and intense courses if students cannot catch the progress of official courses. So we can arrange intensive courses to help the students to catch the official courses. For 9 or 18 or more hours. And that's why the summer camp. So every summer vacation, we arrange summer camp so that not only for international but also for local students, so that they can work together and to have better achievement through holding these summer camps. And in the past 2 years, because of COVID-19, so we are already suspending the summer vacation for 2 years. But this year, we will, as usual, hold the summer vacations for the summer camps. About the industrial link, we know that we have many alumni, and we can have many support, very great support from these alumni. So many presidents of many the professional societies are our alumni. And in addition to the faculty members, we also invite some experienced industry experts to give students lecture about how to practically design the structure and how to practically use what the structure learned from the class to a real application. In addition, we also arrange the field trip so that the students can really feel the practical engineering projects. And because of so many alumni, And then we know that we have many industry academic collaboration projects. So that's why our department has a very good, very outstanding industry academic collaboration performance. And department coordinate practical training with salary, the keyword is salary. So we provide opportunities for students to join practical training, and this is the payable. Okay, so students taking these courses can earn some money for a semester or during summer vacation. In addition to salary, they can also get the credits. For a semester, during a semester, they can get 9 credits. And during summer vacation, they can get 3 credits. Okay, so take a break for 10 minutes. So after 10 minutes, please come back to the classroom. Our department. And then I will introduce when students graduate from our department, what kind of job they can choose. Of course, students can work for industry, government, or academia. For industry, the work types like the planning, design, and supervising in a consultant, the company's contract professional, engineer, and architecture firms. If you are interested in construction, you can work for construction companies, contractors, and so on. And if you are major, if you graduate from if you are graduate students, and you can choose operation and maintenance asset, for example, like asset management companies. Okay, if you have this the ability. For government, including central and local governments. Okay, so the most of Taiwanese students think that this job, working for government, is more stable compared with working for industry. But I have no idea if the concept or if this condition is correct or not. And of course, if you are really interested in researching and teaching, so welcome, to choose academic career. Okay, the teachers in high schools or university professors. Okay, so please welcome to join us. So I just put this picture to show you that this is out of date, the concept cognition. So usually people who are elder always tell you that being a civil engineer, you must be always very dirty because you work at on-site, at construction site. Okay, so if we compare civil engineers with architects, the people's traditional concept is that architects always fashion, have a very beautiful dress and just work, just communication and just work in the office. Actually, this is an out-of-date concept because being a modern civil engineer, in addition to construction work, you still need to learn more things, more knowledges, which usually are related to high-tech technologies. And here, I just want to emphasize that our career is highly related to the people's livelihood and welfare. Also, we have to work. We have many works because the countries or the governments implement policies. The most of policies we have to follow the policies and to do some work. So these policies, for example, like disaster mitigation and prevention, also economic development. Okay, let's show in this figure. You can see that since 1979, so we have many major constructions to construct new infrastructures or to improve our environment so that the country can develop some important policies like establishment of a high-tech park or to develop some biotechnical technologies. So I just use just tell you this long story. My purpose is just to tell you that after graduating from our department, you don't worry. You must have a job, so you don't worry about finding jobs. Because not only industry requirement, but also the government policies. And compared with other industries, for example, now TSMC, the semiconductor industry is very hot in Taiwan. Okay, so if you choose to work for a high-tech factory, of course, in the beginning stage, you must have a much higher salary compared with being a civil engineers. However, for that kind of industry, you are very easily replaced by junior. Okay? So when you get old, you don't have enough energy. And if you do not keep learning, continuously learn new things, it's very easy to be replaced by young people, by next generation. Okay? So, but being a civil engineer, this is an advantage. But you still, keep learning. The more the experience, the more the value. So means that when you get older, and if you have any experience for practical design, practical construction, and you will become more valuable compared with other industry, high-tech factory, high-tech industry. They will become worthless. Okay, so this is the benefit of being civil engineers. And compared with other industry, our end products are usually large scale and durable. So it doesn't mean that you don't take responsibility for your end product, your design product. Actually, on the other hand, you still need to take care of the whole life of these end products. And as I mentioned, in addition to the basic knowledge learned from department, when you start work, you also you still need to keep learning the new things because we know that now we have many high-tech products, but how to apply this high-tech product to our career, to the civil engineering? Actually, this is our responsibility, and only civil engineers have this capability, have this ability. Okay, so this is the value. In our job, our career, as I mentioned, this is a highly related to people's livelihood in the country's economic, especially for economic development. But also, our job, our career, means one of the three principles of the people. The welfare right. What does the welfare right mean? It means we have to satisfy the basic requirement for people, including clothing, housing, transportation, education, entertainment, and food, of course. In addition to these basic requirements, so we also to follow the government, the country's important policy to develop energy, as well as some specific technology like high-tech or biotech. So this is a very simple illustration, but we can just use this very simple figure to emphasize the role of being civil engineers. If you look at the needs, these are basic requirements for people. And the lower the position, the more important the requirement. So you can see that physiological needs are the most important requirements for people, including air, water, food, the shelter, sleep, clothing, reproduction. So if you remember what you learned from the previous slide, actually, this is satisfied. So our job, actually, the achievement, the end product of our job, actually, satisfy this basic needs for people life. So in front here, we to do some representative the construction and the building structures in Taiwan. This one, of course, this is the Taiwan one, and beside Taiwan one, here is another high-rise building, skyscraper, Nanshan, the plaza. And for this one, so when we just completed the construction of this building, this one is the tallest building in the globe. But now it may rank 10 or more than 10 places. But right now this is still the tallest, the building. And for this high-rise, the building, of course, we need to consider some spatial design details. Okay, so this is a basic concept. The Taiwan, we have multiple hazards. So you know that in addition to earthquake, when you come to Taiwan, you may feel that it's very strange. Why Taiwan always has earthquake? Okay, so people are used to earthquake. So if now we have earthquake, if the intensity is not very big, so I will keep my speech. Don't run other way of discussion, because Taiwan people are used to earthquake. So for typical structure, of course, the first consideration for designing the horizontal capability of a structure must be earthquake, seismic load. But for high-rise building, for super high-rise building, the wind load dominate the design details. So in this building, we design the timber standard, remember? Maybe you do not know there is a timber standard in this building, but you can Google, or you can just see the motion of a timber mass during earthquake or during typhoon. Okay, so we have a special design for this building. We equip a timber damper to absorb energy induced by a wind load. Also, this damper can help structure resist earthquake. And this one, I guess, you have ever been here. Xinyi. It's also close to the Taipei 101. This one, This is the most expensive mansion in Taiwan. Okay, it's very regular spatial appearance, architectural appearance. Because of this very irregular properties, so for this building, we designed a seismic isolation system. And this system is composed of a spatial specific isolators, the so-called friction pendulum barrier, so that we can easily overcome the problem induced by this very irregular architectural design. So, you can forget what I tell you now, but you should remember that. Until now, this is the most expensive mansion in Taiwan. So, the elevator is not only for people. You can move your racing car. Right? The elevator can take your racing car from the entrance to your house. And each floor, only one family. Okay? So you can see the whole diversity from different aspects. In Taichung and Kaohsiung City, you can see that they're very crowded, also very crowded, especially for the past 10 years. It developed very soon. And this one is for a housing topic. About the transportation, we also have the very significant development for transportation in Taiwan. Of course, the high-speed rail system in some stations, the high-speed rail system, in the metro MRT system, Taipei and other cities. And this is the third international airport terminal, the third one. Okay, here with the loading. The more and more people like to travel. So especially when now we do not have any limitation for the passenger for the visitors because people are used to COVID-19 now and don't think COVID-19 is not a big deal. And this is a Xueshan Tunnel. So also it's a very important, very top construction project. Transportation also, this is the earliest completed construction project, the bridge. And this is the so-called cable stay bridge. So the cable stay bridge means that we can just use the cable to sustain the vertical load of the bridge deck so that we can elongate the span so as to reduce the number of piers as much as possible. Okay, so its impact is that by decreasing the number of piers, then we can keep the landscape. So we do not affect the landscape. And the specialty for this design is that for this deck can erect by human control, by man control, for the shipping transportation. Okay, so this is another specialty for this bridge design. For the Jingmen Bridge, it just started the operation recently. Okay, this is an overseas bridge. Compared with this one, as I mentioned, this is a cable stay bridge, and this one we use the same principle, but this is a code. This is termed as ultra-dose bridge. Ultra-dose. You can see the difference. For the height, the tower is much higher than this one, right? So this one is not the so-called cable stay bridge. This is an ultra-dose. with the lower tower, the bridge tower. But we still use the cable to sustain the vertical load of the bridge, so that we can elongate the span, each span in there as much as possible. The upper one, this one is a danjang. Okay, when you finish the danjang, and after, I forget when we can complete construction of this project. Okay, so after, this is very close to Taipei City, so if you have time in the future, maybe after 2 years, you can visit the real danjang. And at the end of this presentation, I will also give you some video. So one of the videos is about the construction of the danjang bridge with cable stay bridge. And this is the longest, but for asymmetric cable stay bridge. And of course, another one is the Suhua Highway. And for food, the requirement, of course, the reservoir, the construction, and the irrigation, which can satisfy our food, the requirement, our food need. And the Fei Cui dam, Fei Cui in the reservoir, in the Zhenwen reservoir constructions. So why education? So when we talk about education, so do we have any relationship with education? Of course. After teachers quit, our government started a program, a special program to seismically retrofit existing school buildings. There is cases. So now we almost finished this project, and you can see that during the recent earthquakes, there's no severe damage for school buildings. Okay, so this is a treatment of that program launched by our government after 1999 earthquake. And this one, do you know? Did you visit this one? Okay, in Chinese we always call it 文字馆. The translation in English, mosquito, but I cannot translate, by using the same way, the same words, right? Chinese to English. So it means that after this, the museum is open. The number of visitors are very limited. But for this one, you can see that the appearance, architectural appearance is also very special. So which is the same as that I mentioned, the most expensive mansion, remember? The Chinese name, Taozuyi. Okay, so for the same purpose, this building, the structure is also designed with seismic isolation, with the specific isolators, friction handling factors, so that we can overcome this irregular design. And this one is Tzu Hospital. Tzu hospitals in Taipei, Taichung, Hualien are designed with the base isolation design. So by using the base isolation design, we can absorb the most of the energy through the deformation of isolation system, so that we can reduce the seismic energy transmitted to the structure. Okay? In other words, we can effectively reduce the acceleration of the substructure by using the seismic isolation design. So this is a benefit when we adopt the seismic isolation strategies to list critical important facilities. Other cases for the cases for entertainment requirements. For example, also this is Denmark in Taipei, close to Zhentan Station. Okay, I also provide a video for you to understand the details about the architectural structure design, as well as some introduction about if you try to visit this building, so how to visit the building without buying ticket. Nanyang, the museum, and Taipei Music Center. Okay, I forgot to mention, this is also designed with friction pendulum seismic isolation because of its very, very irregular spatial structure. And this is the Taichung Theater. Also, this is a landmark in Taichung. And Weili, National Gaussian Center for the Arts in Weili area. As I mentioned, in addition to a basic requirement for people, our achievement also meet the policy proposed by the government. Energy industry, the wind energy industry. Okay, so this is also related to our job because this belongs to the part of a construction project. And also high-tech factory and biotech industry. And remember, I mentioned, in addition to basic requirements for people, in addition to meet the policy proposed by the government, if you think after the building construction, then we don't need to take any responsibility for the least existing building. This is not the correct concept. Okay, just like being a doctor, we have to take the responsibility for the whole life of this building. The building, the structure, also has different phases, different stages. Birth, after construction, age, the building gets older. Illness, after earthquake, during earthquake, may be this building is subjected to some damage. If damage is allowable, or if damage is very slight, not very significant, so we can just use our expertise to repair or retrofit or seismically retrofit this damaged building. But based on our expertise, if the building is subjected to a very large, very significant damage, it means that this is dead. Okay? So just like a patient to see the doctor. Okay? The civil engineering is similar to a doctor. And a building is similar to a patient. So let me show you some cases. This building is subjected to severe damage during the Jeju earthquake. Okay, I guess in 1999. I want to say that maybe this year you are, actually I guess you were not born. So you do not have any image or any memory about this earthquake. So this stage, death, okay? So we need to demolish this severely damaged buildings and rebuild another structure. Okay, you should remember this one. This location is in Tainan. There is the building, the residential building collapsed during the earthquake. Okay? Because of the collapse of this building, so we have many dead people, majority people, due to the collapse of this building. This is also in that stage. And Hualien, a similar case. In addition to earthquake, this is the bridge. The damage of this bridge is caused by the flood. And actually, the technical reason is the scouring of the pier. Right? And because of the flood, so we have so many water and water is very strong and very strong, so the water attack the pier. And but based on the design, the requirement, actually the pier can resist the flood, the impact caused by this flood. However, because of a scarring, okay, so it means what is a scarring? Originally we decide the height, the nominal height of the pier. But when flood attack the pier, maybe they also move some the rocks. So the back rock may become lower. In other words, the pier, the height, the length of the pier becomes larger. In this case, under this circumstance, this pier has more damage potential. Okay, so this is a scarring. So this is another case, the damage case used by another hazard. Also, I just use this problem to emphasize that our diversity. This is a Taipei arena, and what problem for this Taipei arena? So we do not have a structural problem, but the Taiwanese student should know, Zhang Huimin, a very superstar in Taiwan. And when she hosts a concert, the residents close to this arena always complain. Not for noise, but for vibration. And this vibration, of course, is not directly caused by Zhang Huimin, the singer, but it's caused by the jumping of the audience. Okay, the vibration caused by jumping will be transmitted to the area nearby this arena, the type of arena. So the residents always complain. So being a civil engineer, so we also need to solve this problem to reduce the vibration caused by a concert as much as possible. So therefore, we try to review the remodeling the building, and then find out what's the problem, so what strategy we should take to improve the situation. And this picture just to show you that Taipei, the night in Taipei is very beautiful. Okay, we have very beautiful night scene in Taipei, and you can also observe that Taipei is very, very, very crowded. It's highly populated with so many buildings, but most of these buildings are very old buildings. Therefore, this is a major problem. Taiwan, we know that we have multiple hazards. And according to the statistics, in average, every year, so it may not have this concept, but we have totally 23,000 earthquakes. Among these 1,000, you can feel the 1,000 earthquakes. And among 23 earthquakes, there is one destructive earthquake, which that it will damage the structure as well as cause some death or injured people. So, if we talk about the hazard, especially for multiple hazard, because in addition to earthquake, we also have flood, typhoon, right? So Taiwan is should be the top 5 in the global. If we just talk about the hazard, this issue. The final goal, of course, this is impossible to seismically retrofit all of this existing building, right? But at least we hope that we can make the resilient city. The concept is just like a sponge city. Okay? So we don't hope that all the buildings are very strong, so they can safely resist earthquake. But at least we hope that after earthquake, this city can recover. In other words, they can still provide the functionality as usual. Okay? So this is the concept of developing a resilient city. Let me take an example. This is in New Zealand before the Christchurch earthquake. Okay? So this is the briefing of the whole city, the Christchurch, in 2011, and after earthquake. Okay? So you can really feel the impact caused by this earthquake. Almost all the buildings were demolished because of this earthquake. Okay, so let's take a few minutes to see some videos, and then you can really feel some impact if you hope to be a civil engineer, and then so what are the achievements you can have. And this video is provided by Sono Dynamic, one of the biggest consulting companies in Taiwan. And this is the design and construction of the Danjiang Bridge. Remember, this is the so-called cable-stay bridge, but this is a symmetrical design. So this is the longest cable-stay bridge, but we just focus on a symmetric cable-stay bridge. So this is the longest span in the globe right now. And tower foundation, construction. And the on-site lift on the shipping to perform the construction. So from both sides, we start the construction of the deck, of the bridge. And, at the same time, we also construct the tower, so that we can connect cable from tower to deck. So this is a so-called free cantilever erection. So for the last piece is very important because we need to accurately connect using this piece to connect both sides. And the approach, the main body and the approach from the land to the bridge. So, and we reduce the environmental impact as much as possible. So that by using this spatial design, the cable stay the bridge design, you can see that they still keep the existing land scale. In other words, we do not affect the environment too much. Okay, the next one. This is about the design of the Taipei Performing Art. Jinan Station close to the Shili Line Market. Boy, this is not loud enough. Okay, so the site, construction site goes to the Shiliman Market and Jinan Station. So this is a construction site. So this building has been completed. Okay, so if you want to visit this building, so you can just take the MRT to Jinan Station and walk a few minutes, very close. A very spatial, irregular. Structural appearance and composed of three major bodies for the whole structure. So this is from the different aspect to view this building. Okay, here it's mentioned that even you do not buy a ticket, but you can still use the public way. The public, the escalator, just take the public escalator, so you can also visit the exterior and interior of this building. Three parts. It's composed of 3 parts. And you can use the space, and also you can use a separated space for each part. This is a very convenient design, and also consider all the scenarios where we use this building. And this building is provided by one of the biggest consulting company, the Evergreen consulting, research consulting company. Okay, so it's almost the time to end this class. But before we leave this classroom, any question or any comment? No? If no, even if they have passed, but they're happy, the weekend, enjoy your weekend. Thank you.